In our previous video, we solved the Fourier series representing f of x equals to x, and we had its answer. Now, in this video, we'll be talking on the Fourier series representing f of x is equals to x squared, and the range we are given 0 less than pi less than or equals to 2 pi. So, as usual, as we've done before, we have to evaluate a0, an, and bn, and then our final answer will be slotted into a0 over 2 plus summation of n is equals to 1 to infinity of an cos nx plus bn sin nx. Now, with this understood, let's go into a0. The a0 from this formula is 1 over pi integral of 0 to 2 pi f of x dx. Now f of x is equals to x squared. So this is 1 over pi integral of 0 to 2 pi of x squared dx. Now this will give us 1 over pi. Integrating x squared, we have x cubed over 3 of 0 to 2 pi. And we now add our upper limit and subtract it from the lower limit. So this will give us 1 over pi of 2 pi cubed divided by 3 minus 0 raised to 3 divided by 3. This gives us 0, and we'll be left with 1 over pi. So 8 pi cubed over 3. And this is equal to 1 over pi times 8 pi cubed over 3. This will be equal to 8 pi squared over 3, which is a0. And we have been able to establish for a0. It is now time to find an, evaluate an. And the formula is an is equals to 1 over pi integral of 0 to 2 pi of f of x cos nx dx. an is 1 over pi integral of 0 to 2 pi of f of x cos nx dx. Now we recall that f of x is equal to x squared from the question. So when we substitute that, we have 1 over pi integral of 0 to 2 pi of x squared cos nx dx. Now with that done, we go back and look at our theorem of integrating uv. So give us u v1 minus u prime v1 v2 plus u prime prime v3 minus dot dot dot. Now our u is equal to x squared and our v is equals to cos nx. Now u prime is equal to 2x, u prime prime, that means we are differentiating 2x again. We'll allow it to be x, so 2, sorry, and u prime prime prime, we'll have it to give us 0. Also, our v1, for v1, we are going to be integrating v dx, and that will be integral of cos nx dx, and the integration of cos nx dx is sin nx over n. v2 is integral of v1 dx, and that will be integral, and v1 is sine nx, integral of sine nx over n dx, and that will give us minus cos nx over n squared. We've established these things in the previous videos. And v3 also will be integral of v2 dx. That will give us integral of minus cos nx over n squared dx, and this will give us minus sine nx over n cube. So moving on, we continue solving for an, which will be 1 over pi, and we apply this formula to it, where u is x squared and b is cos nx. So we start with u is x squared, v1 sine nx over n minus u prime, which is 2x, multiplied by v2, which is minus cos nx over n squared, plus u prime prime, which is 2, and v3 minus sine nx over n cube. And remember, we are dealing with the range of 0 to 2 pi. 0 to 2 pi. Now we proceed further. So we have an is 1 over pi for x squared sine nx over n minus 2x will multiply minus cos nx over n squared to give us plus 2x cos nx over n squared, and we have minus 2 sine nx over n cube from limit of 0 to 2 pi. The next thing to do is to apply the upper limit of 2 pi minus the lower limit of 0. So we have an is equals to 1 over pi. We'll deal with the upper limit first. So where we have cx, we add 2 pi. So we have 2 pi squared sine n of 2 pi over n plus 2 into 2 pi cos n 2 pi over n squared minus 2 sine n 2 pi over n cube, and then we subtract it from the lower limit. So this is the lower limit of 0. So where we have cx again, we change it to 0. So we have 0 squared sine n of 0 over n plus 2 into 0 cos n of 0 over n squared minus 2 sine n of 0 over n cube. Now in our previous video, we understood that cos n 2 pi is equal to 1, sine n 2 pi is equal to 0. Also, cos n of 0 is equal to 1, and sine n of 0 is equal to 0. So with regards to that, this we cancel out to give 0 because it has sine n 2 pi. This can also cancel out to give 0 because it has sine n 2 pi. This cancels out to give 0 because it has sine n 2 pi and it is also multiplied by 0 squared. This we cancel out to give 0 because it is multiplied by 0. This we cancel out to give 0 because it has sine n of 0. So thereafter, we are left with 2 into 2 pi cos n 2 pi over n squared. So an is equal to 1 over pi into 2 into 2 pi of cos n 2 pi over n squared. So in essence, an is equal to 1 over pi multiplied by 4 pi cos n 2 pi over n squared. Pi can cancel out pi. I'm left with 4 cos n 2 pi over n squared. Now, since cos n 2 pi is equal to 1 when n is even and odd, we established this in the last video. Therefore, we can say that an is equal to 4 over n squared. Over n squared. Now we have evaluated for an and we have as well evaluated for a naught. The next thing to do is to evaluate for bn. Bn is 1 over pi integral of 0 to 2 pi of f of x sine nx dx. So bn is equal to 1 over pi integral of 0 to 2 pi f of x sine nx dx. And the question is referring to f of x is equal to x squared. Now moving on, let's substitute f of x is x squared. So we have 1 over pi integral of 0 to 2 pi x squared sine nx dx. As usual, this is integration of two terms of u and of v, which brings us back again to the process of differentiating uv to be equals to u v1 minus u prime v2 plus u prime prime v3 minus u prime 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 v4, and it continues. Okay, so we know that our u is x squared, and this time around our v is sine nx. So our u prime, that's differentiating x squared, is 2x. Our u prime prime differentiating 2x, which is 2. And our u prime 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 differentiating 2 is 0. Now our v1, which is integrating v with dx, which is integral of sine nx dx, and integrating sine nx dx, we'll have it to be minus cos nx over n. Also v2, which is integral of v1 dx, is equal to integral of cos minus cos nx over n with dx, and integrating minus cos nx over n dx, we would have minus sine nx over n squared. And finally v3, which is integral of v2 with dx, is integrating minus sine nx over n squared with dx, and integrating this, we have it to be cos nx over n cubed. Now, having understood this, we can go on and evaluate bn to be equals to 1 over pi. We are applying this formula here, starting with u, and u is x squared, followed by v1. v1 is minus cos nx over n, minus u1, which is 2x, followed by v2, which is minus sine nx over n squared, plus u prime prime, which is 2, followed by v3, which is cos nx over n cubed. And we are dealing from a limit of 0 to 2 pi. Now, we do not include u prime prime prime, that's triple prime, because it is 0, which will eventually cancel out. So, simplifying further, we have bn to be equals to 1 over pi into minus x squared cos nx over n plus 2x sine nx over n squared plus 2 cos nx over n cubed. From the limit of 0 to 2 pi. The next thing we to do is to input our upper limit and subtract the lower limit from it. So bn is 1 over pi, starting with the upper limit of 2 pi. And I will see, wherever we see x, we add 2 pi. That's minus into 2 pi squared cos n 2 pi over n plus 2 into 2 pi sine n 2 pi over n squared plus 2 cos n 2 pi over n cubed. Then we move on to the lower limit of 0. So wherever we see x in this equation here, we add 0. So we have minus 0 squared cos n of 0 over n plus 2 of 0 sine n pi or sine n of 0 over n squared plus 2 cos n of 0 over n cubed. Now with that done, we have to reduce the terms. So in reducing the terms, we recall that cos n 2 pi is equal to 1, sine n 2 pi is equal to 0. Also cos n of 0 is equal to 1, and sin n of 0 is equal to 0. So we can reduce the term further such that this contains sin n of 2 pi, and since sin n of 2 pi is 0, this term is 0, and since this guy is multiplied by 0, this term also is 0. Same thing applies here, multiplied by 0 turns to 0. And then let us write out our cos variables. That's 1 over pi into minus 2 pi squared cos n 2 pi over n plus 2 right here now cos n 2 pi over n cube minus 2 cos n of 0 over n cube. Now, since we have considered this to be true, this to be true when n is even and odd, so we can apply them to this. So Bn is 1 over pi. So wherever we see cos n 2 pi and cos n 0, we can replicate it with 1. So we have minus 2 pi squared multiplied by 1 over n plus 2 multiplied by 1 over n cube minus 2 multiplied by 1 over n cube. So this gives us Bn is equals to 1 over pi of minus 4 pi squared over n plus 2 over n cube minus 2 over n cube. 2 over n cube minus 2 over n cube is equal to 0. So in essence, we have that Bn is equal to 1 over pi multiplied by minus 4 pi squared over n. And Bn is equal to minus 4 pi over n. Now we have been able to evaluate A naught, An, and also Bn. So let's bring them all together. That A naught is equal to, as we calculated earlier, A naught, A naught is equals to x 8 pi squared over 3. An is equals to 4 over n squared, and Bn is minus 4 pi over n. So A naught is 8 pi squared over 3. An is equals to 4 over n squared, and Bn is minus 4 pi over n. Now, if you impute it into the Fourier series formula, this says f of x is equals to A naught over 2 plus summation from n is equals to 1 to infinity of An cos nx plus Bn sin nx. So we can substitute our terms of A naught and substitute our terms of An and as well of Bn. So in since we have f of x is equals to A naught, which is 8 pi squared over 3, everything multiplied by 1 over 2, plus summation of n is equals to 1 to infinity, where An is 4 over n squared multiplied by cos nx, plus Bn, which is minus 4 pi over n, multiplied by sine nx. Now, since minus we multiply plus to give minus, we can as well just change these two to give minus. Now we can leave our answer in this format, or we go ahead and open up 4 over n squared, 4 pi over n individually from 0 n is equals to 1 to n is equals to infinity, since it's more or less like a series. So solving these, we have that f of x is equal to 4 pi squared over 3 plus summation of n is equals to 1 to infinity of 4 over n squared plus nx minus 4 pi over n sine nx. Now, if we take them bit by bit, so we have that f of x is equals to 4 pi squared over 3. So we start with this. When n is equals to 1, we have 4 over 1 squared plus x. When n is equals to 2, we have 4 over 2 squared plus 2x. Plus when n is equals to 3, we have 4 over 3 squared plus 3x. And it continues. Also, you can do for this. When n is equals to 1, we have 4 pi over 1 sine x. When n is equals to 2, we have minus 4 pi over 2 sine 2x. When n is equals to 3, we have minus 4 pi over 3 sine 3x. So simplifying further, we have that f of x is equals to 4 pi squared over 3 plus 4 plus x plus 4 over 4 plus 2x plus 4 is over 1 plus 4 over 9 plus 3x plus minus 4 pi over 1 sine x minus 4 pi over 2 sine 2x minus 4 pi over 3 sine 3x. Now we can see that 4 is common to all. So we can see that f of x is equals to 4 being factorized out of pi squared over 3 plus cos x plus 1 over 4 plus 2x plus 1 over 9 plus 3x plus minus pi sine x minus pi over 2 sine 2x minus pi over 3 sine 3x. So this brings us to the end of the question. In our next video, we will talk on non-periodic functions.